Shipyards. They're giant waterside construction sites where the extraordinary takes shape. Places where the largest of machines are constructed, retrofitted, and repaired. In times of peace, they create the vessels that carry commerce and international trade. And during war, they build the mightiest weapons the world has ever known. On the shores of the Chesapeake Bay sits one of the United States' largest and oldest shipyards. The sprawling 500-acre Northrop Grumman Newport News facility is situated on nearly 2 miles of waterfront. Workers at the facility are responsible for building and maintaining U.S. aircraft carriers, the most complicated warships to ever rule the waves.
When we bring people into the shipyard, invariably that's the first thing. When you look at an aircraft carrier, they walk up to it, and it's hard to conceptualize that what they're looking at is a ship, because it takes up the entire horizon. And when you think about putting that ship together and starting with a plate of steel or that piece of pipe, it is an awesome challenge, and it is a deep sense of pride when you get to the finish line.
Carrier construction can take nearly 8 years and relies on nearly every muscle that the shipyard has to offer. Because multi-ton ship parts can't be picked up at the local home improvement center, shipyards have to build everything they can't buy.
Shipyard is a huge place. At one point in time, we had the capacity to do everything that was in the ship. Over the years, we've become more specialized. We've retained certain core capabilities in the shipyard. One example is our foundry.
Workers within the over 250,000 square foot foundry pour up to 2,900 degree Fahrenheit molten metal into castings to form many of the ship's unique pieces.
We also have other shops that make up the individual components. We have electrical component shop, we have pipe shop, we have a machine shop capable of machining anything you would ever want to machine. All these shops are equipped with the state-of-the-art equipment.
But all these shops could be part of any huge industrial work site. What sets shipyards apart is the size of the material being created, and the fact that the final product must eventually find its way to water. Enormous dry docks are how many shipyards deal with both problems.
I'm standing on top of the intermediate gate in the largest dry dock in the Western Hemisphere. Here at Northrop Grumman, Newport News, the purpose of this intermediate gate gives us the option to divide this dry dock up into 2 sections. It's 2,173 feet long and 250 foot wide with a depth of about 40 feet. What you see here is just half of this massive dry dock. The other half is behind me.
A dry dock is a concrete berth with a watertight gate at one end. Inside these often massive enclosures, shipyard workers both repair and build vessels. During ship construction, the dry dock is the focal point of the yard, where towering pre-assembled modules are joined together. But as with all modern shipyards, the building process starts small.
The construction of the components for the carrier start in the steel fab facility, where we built small pieces, bulkheads, girders, foundations that come together to make up pre-assemblies. Those bigger pre-assemblies are then brought together in another shop to make sub-assemblies, which are a little bigger. These can get up to 50 to 150 tons.
Over the course of months, workers weld, fit, and connect multiple sub-assemblies into even bigger modules. The largest of which are called superlifts and can weigh in at a staggering 900 tons. To move these enormous ship elements, workers make use of one of the shipyard's most conspicuous pieces of equipment, a crane. But like everything else in the shipyard, these construction tools are on a supermassive scale.
At the far end of the shipyard, there's a crane. We call it the 900-ton crane. And we call it the 900-ton crane because that's the capacity for a lift. And you say, well, what other business would require such a crane? And there probably aren't any. Those kinds of things are unique to shipyards.
Crane's 540 feet wide, it's 290 feet tall. It weighs approximately a little over 10 million pounds, has 37 miles of electrical cable. At full power, it uses enough power to supply 114 houses. People don't really understand how big the crane is. The letters on the crane are 3 stories tall.
You consider the size of the product that we're producing.
The vessels the craftspeople create are the end product of a long evolutionary process, spurred through the ages by revolutions in the shipyard. For ancient civilizations, shipyards like these didn't exist. And scientists who look for these early construction sites engage in a frustrating task.
We know they're supposed to be there. We haven't found one yet, or at least we don't think we found one. So we're waiting for the next great discovery, the breakthrough. Archaeologists are incredible optimists, and every time I go in the field, I hope this is the time. I'd like to find one. A good number of the ancient sites that we're interested in, where we know there were shipyards, are now still functioning as harbors. So you've got the modern overlaying the ancient. And the second thing is, they were never very major installations. Ships in antiquity were built on the beach, simply propping up a hull that was going to be worked on. That's still being done in places like Turkey and Greece today. And that's what would have been done in antiquity.
But some evidence of early shipyards does exist. For the Egyptians, clues to theirs are appropriately buried with their dead.
We're very fortunate to have a number of depictions of boats and ships being built, presumably along the Nile, presumably in shipyards by definition. There's one painted relief in a tomb belonging to a guy by the name of T that dates to the latter part of the 3rd millennium BC. You have people lobbing the branches off logs. Then you have planks with people sitting on top of them, cutting mortise and tenon joints into the planks. And they would do this with a chisel and a mallet.
Throughout the Greek and Roman empires, the Middle Ages, and into 15th century China, where massive 400-foot-long wooden ships were constructed, design and vessel size were altered greatly. But the yards, techniques, and tools used to build them remained little changed. For Italian shipwrights and European master carpenters of the Renaissance, the 2 most important attributes of a shipyard were a gently sloped piece of land and a deep water channel. In the yard, workers used a chopping tool known as an adze to hew and shape the internal timber frames, while the mechanical advantage provided by block and tackle, coupled with animal power, helped shipbuilders to lift heavy masts and yard arms into place.
The hammers were there, the chisels were there, the adzes were there, but nothing very complicated. You have to realize that this was a labor force that very often had very little training. Shipwrights themselves, there were some people who built ships that were in fact extremely well trained, but they often worked with a lot of people who weren't. You had to keep things very simple. And I think sometimes we have a tendency, because of the world we live in, to think that only complexity will get results. Well, that's not the case.
By the end of the 18th century, trade began to fuel industrialization, and the goods being carried and the waterways on which they traveled began to change ship design. Growing nations realized their prosperity was tied to the ships they sailed, and it fell to the shipyards and craftspeople to help build that future. During the 17th century, the British were one of the world's leading shipbuilders. Both an island nation and world power, Britain depended on its navy for international trade and to defend its vast holdings. Ships built in English port towns such as Portsmouth were constructed and repaired in some of the best shipyards of the day. Soon after the creation of the Royal Navy in 1670, the British government built the world's first stone dry dock. Also known as a graving dock, it allowed the British to repair their large ships of the line in a permanent and dry facility.
And those docks are still in existence today and are still being used. One actually is the permanent home of the HMS Victory.
Roughly 50 years after its founding, the burgeoning United States commissioned the first American graving docks. In 1827, engineers began building two, one in Boston, the second on the Elizabeth River in Portsmouth, Virginia. The civil engineering feat was one of the greatest the fledgling nation had ever undertaken.
To dig this hole in the ground in 1827 was an extraordinary event. They had to excavate this hole that was 400 feet long, approximately 20 feet deep at least. Then below that, they had to drive the piles down. Piles were like telephone poles. On top of these piles, then they laid and cut granite stone.
For early shipyards that specialized in repair, the dry dock was their single greatest physical asset. But other American yards in the business of building new ships relied more on a form of shipyard natural selection for success.
The history of shipbuilding in the United States goes back to the colonial time, because the East Coast was fortunate in having many small protected harbors, tidal areas where wooden ships could be built, and a great store of timber standing right nearby that could be used to build these ships.
In the U.S. from 1820 to 1890, more ships were built in Maine than anywhere in the United States. And due to unique geographic conditions, a majority of that building was done near the small town of Bath.
The reasons for it included the availability of natural resources, a skilled labor pool, and, as importantly, a long stretch of the river from Hospital Point to Day's Ferry, 3 miles, where the western shore, the Bath side of the river, was far enough away from the river to accommodate the length of the vessels being built. Vessels couldn't be built on the opposite shore, the Aroostook shore, because of how steep the shore rises up out of the river.
The coastline around Bath allowed building sites such as the Percy and Small Shipyard to create mammoth wooden vessels, some of the biggest to ever take to the waves.
One of the most important ingredients of a shipbuilding site like this here at Percy and Small's South Ways was finding an area, first of all, big enough to build the vessel one wanted to build, and secondly, one that had just the right slope to the land. It's hard to see, but this land here slopes about 3/4 of an inch to a foot down to the river, just right to launch the vessels that were built here.
The launching of a ship had changed little since antiquity. Workers built the vessels on top of wooden rails, known as ways.
This is a model we use to demonstrate launching the completed wooden vessel. It would have been built right here in its position on top of the tracks or launching ways, but shortly before launching, a cradle would have been constructed on top of the ways between it and the bottom of the vessel. Just before launching, the 2 halves of the cradle would be snugged up against the base of the hull by wedges driven in between the 2 halves of the cradle. And then at just the right moment, at precisely slack high water, when there's no movement in the river at all, the keel blocks would start being knocked out from underneath the keel, and finally, at just the right moment, the vessel would slide, hopefully, into the river.
The men who split out the blocks from under the tons of teetering ship had one of the most dangerous jobs in the yard. But they also had an upfront seat for the shipyard's most awesome spectacle.
If one could have been standing here then and looking behind me and watching one of these big vessels take shape, ultimately at the right moment one would have watched it smoke past us with great thunder and applause and smoking timbers as it took to the Kennebec River.
Besides a near-perfect natural environment, Maine had another shipbuilding asset: its people. 19th century shipyards were less of a physical establishment than a local gathering place. As had always been the case, whole communities were part of the shipbuilding process.
In communities where there were many shipbuilding facilities, there were often tradesmen who set up shops that supplied services to many different shipyards. For example, a painter might go to paint vessels at various shipyards. A ship carver might produce lots of ship carvings, figureheads, trail boards, other carvings to decorate vessels built in many different shipyards. This is basically from the beginning of time to the end of wooden shipbuilding.
But one change during the 19th century began the modern transformation of the shipyard: energy.
As power is introduced, we see shipyards begin to take the physical form that we recognize as a shipyard today. Space filled with shops for protecting the machinery that's used to produce the various parts of a vessel.
First steam and then electricity powered the tools and mechanized jobs once done entirely by hand, such as the cutting of wood and timber for the vessels.
All of the heavy wood that was shaped here at the mill was done with the aid of heavy machinery, most of which was run from a belt and shaft system that came across the top of the mill building. This machine for shaping heavy timbers was known as the Daniels planer. It had a circular cutting head that would go around at a great rate of speed and could take up off to 2 inches at a time. The chips flew with such force that they actually gouged out areas of the ceiling and walls of the mill all around them. But all in all, it was a fairly effective tool for cutting down very, very thick and heavy pieces of timber.
The shipyard's ability to use power tools to shape and trim the lumber allowed for greater efficiency in shipbuilding. Other trades began to appear within the yard. Workers once hired on a per-ship basis found it more economical to set up shop right on the premises. Permanent design buildings such as mold lofts became part of the shipyard complex.
There were literally dozens of different trades that went into the making of a wooden ship. And in a 19th century shipyard like this, it all began here in the mold loft where the design started to take place. The designers would come up with a half model of the vessel, take its measurements, and blow them up full size here on the mold loft floor. That was in order to create patterns that could then be used to cut out the right shaped timbers to build the schooners. Every single piece of wood that went into the frame of the schooner had to be sketched out first. That's why the mold loft became such an integral part of a shipyard like Percy and Small.
Carpenters, overseen by master builders, then began the arduous task of assembling the timbers that eventually became the ship's hull. Within the shipyard, workers constructed the frames on a platform attached to the keel. When a frame piece was complete, oxen or horses pulled the frame down to the emerging hull, where it was raised into position by animal power, using block and tackle. Countless tradespeople in turn added their skills to the growing vessel. Everyone from plankers and caulkers to sailmakers were necessary in the 19th century shipyard. But the greatest change for shipyards and builders came with the crossover from wood to metal in the late 19th century. Hewing of timber and sewing of sails, jobs that had been performed for millennia, would all but disappear as the world's oceans began to be traversed by floating steel. Riveters, torchmen, and ironworkers began to populate the yards, each with their own tools and crafts.
When you're dealing with riveted construction and steel, obviously the weight or displacement of these ships is going up dramatically. One of the key things they need to invent in the yards were cranes, something to pick up the heavy weight. They start out with steam-powered cranes that really they're called portal cranes that go around the side of the dry dock and have the large arms with the hook on the end that they can pick things up. And then they eventually shifted over from steam to electric.
The powerful cranes came just in time to lift shipyards into a new century. A century that would see both the triumph of the massive steel vessels and the stunning destructive power unleashed by shipyards over the course of 2 world wars. Modern shipyards owed their very existence to the evolution of building materials and craftsmanship. By the beginning of the 20th century, shipyards had undergone an epic change. The wooden ships that had brought the world closer together were now sailing into history. Industrialization and technology were replacing wood with steel. The age of the mammoth metal ship had begun.
The thing about steel shipyards is that they do not come from wooden shipyards. The guys that have spent their lives building wooden sailing vessels are not going to wake up one morning and go to a different shipyard and be able to build steel vessels. The workforce for shipyards that build steel vessels comes from the foundries and the boilermakers.
The new materials demanded precise work. Designers and naval architects began to be shipyard regulars, as the old days of shaving wood with hand tools gave way to industrial presses that cut metal to exact specifications. In the United States, the technology began to change the yards, but it would take the First World War to unleash the nation's true shipbuilding potential.
When World War I began in August 1914, the U.S. had for years been depending on the ships of European nations, primarily England, Great Britain, but also France and Germany, to carry American commerce to the world.
As foreign governments pressed their ships into military service, America needed to build overseas transportation. As a result, the U.S. underwent a shipyard building boom.
The foremost government project for shipbuilding in World War I was the installation at Hog Island, which was a kind of mud flats in the Delaware River near Philadelphia. And the government moved in with contractors. You're taking essentially an undeveloped space. You had to bring in all the machinery to move metal pieces, to the shops to support, to fabricate.
The Hog Island site cost over $65 million to build. For workers, the biggest job was stabilizing the barren, muddy land that sloped into the water. Steam-powered pile drivers pounded telephone pole-sized logs into the muck for support. The defining feature of the mammoth construction site was the building of 50 shipways, able to accommodate vessels nearly 400 feet in length and over 50 feet wide. On either side of the shipways, permanent cranes were positioned to move the massive bulkheads and plate steel into position. At the height of production, over 30,000 shipyard workers manned the tools at Hog Island. But despite their best efforts, the shipyard had almost no impact on the war. The first ship built at the Hog Island facility didn't slide down the ways until August 5, 1918.
Building a ship is a very complex process. A ship is the biggest movable thing that humans make. The logistics of that construction process are extremely important.
The yard's designers had envisioned Hog Island as a fast-paced cargo ship assembly yard, where pre-built boilers, engines, propellers, and shaped steel arrived on train cars from manufacturers around the country. Unfortunately, the erratic supply stream and simultaneous site construction initially lowered the shipyard's efficiency. It took up to a year to complete a vessel.
Cargo ships, the ones that were built for the war, were perfectly useful in commercial trade. So here's this flood of ships now made available after 1920 to the private operators, driving down the price of hulls because there are so many of them competing for the small market. The shipyards can't produce new ships, and the industry was in depression before the depression began in 1929. It went from bad to worse.
Throughout the Great Depression, American shipyards closed at an alarming rate, while the ships built during the First World War became more decrepit with each voyage. During the 1930s, President Roosevelt, frustrated by America's failing shipyard industry, created the U.S. Maritime Commission to modernize the U.S. merchant marine. The commission worked to design a standardized set of ships to carry U.S. goods and oversaw the funding for shipyards to mass produce the new vessels.
You go to the Maritime Administration and say, I'd like to build a new ship. They say, fine. We will find out what it would cost to build that ship at world rates. That is to say, at the lowest cost adequate shipyard in the world. Then we'll find out how much it would cost to build it at a U.S. shipyard. We'll pay the difference.
The subsidies program began to resuscitate the merchant shipyards. Meanwhile, Congress, fearing a second great conflict, recognized the need to build more warships, as well as repair facilities, to take care of the Navy's wide-ranging fleet.
An explosion occurred really starting in 1938 throughout the World War II period, but the period between 1942 and 1944, 26 huge graving docks were put in service. In the entire previous history of the United States, only 29 graving docks have been put in service. And here in a period of 2 years, 26 graving docks.
The new facilities sprang up on both coasts, as well as Puerto Rico, Panama, and Hawaii. Engineers designed the new docks with the mammoth warships of the day in mind, and built some to repair multiple vessels simultaneously.
These were 1,092-foot-long graving docks. They weren't 300 feet. These were for the big ships, for the carriers. These dry docks were way over 100 feet wide, about 150 feet wide, and over 40 feet deep. And they need a lot of them.
New underwater concrete technology allowed workers to cut construction time on these new docks from years to months.
The method is called the Tremie method, and basically it's a way of pouring concrete underwater. Before, he had to actually put cofferdams up and pump all the water out and make it dry before he could lay the concrete. But this was a way they could actually dredge out the area for the graving dock, place the forms down underwater, then actually through pipes lay concrete underwater.
Two of the Navy's graving docks were put to the ultimate test during the event that thrust the U.S. into war, the Japanese attack at Pearl Harbor.
One of the errors that the Japanese made on December 7th, they didn't totally destroy the shipyard, specifically the dry docks. They did bomb the ships that were in the dry docks. The Pennsylvania, the Downs, the Cassin were in dry dock 1. They were all terribly damaged, but they didn't destroy the dry dock.
Within weeks after the attack, shipyard workers were able to put numerous ships, including 3 heavily damaged battleships, back into service. 2 additional battleships, too badly damaged to repair, were stripped clean, and their equipment and weapons were installed in new hulls at the San Diego Naval Yard.
There was 7,000 dry dockings during World War II, utilizing all these dry docks. So you could see the importance of dry docks in the war effort. Really, I think, turned the tide during the Pacific War. That was one of the key factors that made these ships available out there, was having these repair assets available.
Some of the Navy's wartime repairs were performed in 142 newly built floating dry docks. Some were individual modules that could be towed almost anywhere. Part repair facility and part submarine. Once fitted together, yard workers could open valves which flooded and submerged the structure. When the vessel was in place, water was pumped out of the dock, causing it to rise, leaving the ship high and dry.
During the Second World War, repair became very important, especially for the Navy, for 2 reasons. One was to repair battle damage, but the other thing was the technology was changing so fast, for example, with radar and the electronic systems, that there was a tremendous amount of work that had to be done to keep the ships up to date so that the ships were technologically superior to our enemies.
But while some shipyards labored to keep the fleet afloat, others were welding and lifting their way into the record books. The United States was in the middle of a shipbuilding boom, and the shipyards were being called on to back the nation's war at sea. The carnage and destruction of World War II brought a golden age to American shipyards. Over 500,000 workers, many of whom were women, produced over 5,000 vessels for the war effort. Military ships were a clear necessity. At peak production, one shipyard, the Bath Iron Works in Maine, was able to launch a new destroyer every 17 days. But the true pinnacle of wartime shipbuilding was reached with the over 440-foot-long cargo carriers known as Liberty ships.
In World War II, when we were building the Liberty ships, and every ship was the same, as they built more and more ships, the production workers got better and better because they found little ways that they could build the ship faster.
By 1943, many yards were producing a Liberty ship every month. One ship, the Robert E. Perry, was constructed in a record 4.5 days. Upon hearing of the speed at which they were produced, Hitler reportedly stated, "We have lost the war." The shipyards themselves were little changed. But inside, a revolution had taken place. Shipyard workers relied on new modular construction techniques, taking prefabricated pieces of ships and welding them together, as opposed to using the older, much slower riveting process. But part of the Liberty ship's success was due to the use of technology developed over half a century earlier.
The technology utilized for the massive shipbuilding program in World War II was predominantly late 19th century propulsion technology. Also, the hull forms and the metal shaping were essentially late 19th century.
Cutting-edge technology often requires a steep learning curve. Yard workers familiar with tried and true old ship construction methods were able to assemble the vessels with relative ease and help win the war. But as with the end of World War I, when hostilities ceased, the heightened wartime production of cargo ships nearly devastated a portion of the industry.
With this enormous surplus of cargo carrying ships at the end of World War II, the shipyards again had practically no business building cargo ships. But they were busy with the Cold War building military ships, naval ships. And so the shipyards were very busy, and the United States remained fully armed in naval terms after World War II.
After the war, existing shipyards were redesigned to build and maintain ever larger ships. Engineers relied heavily on the modular shipbuilding techniques pioneered during the war. But now the individual pieces were building-sized structures, being hoisted and lowered by massive overhead cranes. But there was a downside to building on an epic scale. When a mistake was made, it was usually disastrous. The size and complexity of these new vessels caused shipbuilders to rethink one of the oldest shipyard traditions.
Historically, shipyards built ships on ways. And the way was basically inclined so that I could use the force of gravity. When I released the ship from its holding condition, it would slide into the water. Well, if you think about trying to build something that's level, it's very difficult to do it if it's already on an incline. So if you build basically a land-level facility where everything is referenced to a flat surface, it's much easier to assemble everything. So in the 60s and the 70s, the shipyards have transitioned from these launching ways where the ship is going to go down at an angle into the water to vessels that I'm going to build on a flat surface and launch it.
In many shipyards, dry docks became the prime building areas, but that wasn't always the case. Specialized rail and lift systems began to be incorporated in many yards. Like a locomotive switching yard, ships were built and repaired on side tracks. The ships were then towed by tractors onto a hydraulic central track and moved almost anywhere in the yard. The technology allowed the shipyards to keep pace with the changing business.
In the 1960s, shipyards did something called jumboizing. I had ships from the Second World War that there was still good life left in the machinery, the propelling equipment of the ship. However, the cargo carrying capacity wasn't quite large enough. So we'd bring the ship into a shipyard and we'd basically cut the machinery away from the cargo section, throw the cargo section away and install a new cargo section that was larger that we had already built and was waiting for the ship to arrive.
But some of the biggest changes for shipbuilders took place inside the ships. Within a decade after the war, the U.S. Navy began to use the same atomic energy that had so chillingly and effectively ended the conflict to power its new breed of ships. The shipyards of the 1950s and 1960s took responsibility for the nuclear vessels.
The nuclear yards obviously had things they had to worry about that the others may not have to worry about, but specific craftsmen required, people that were familiar with this type of work. It took, of course, increased training, and it took some special equipment that was available at the yards and additional security and that type of thing. But I think you'll find that all the naval shipyards had a similar type of set of skills and similar shop names and similar tools.
America was now building some of the best warships the world had ever seen, and a handful of shipyards were pushing technology to the limits. But the Navy's triumphs belied a serious problem. U.S. shipbuilding was on a steep decline, and over the next few decades, conspiring forces would push American shipyards to near extinction. At the start of the 1980s, America's shipyards were entering a period of production not seen since the Second World War. The Cold War had led to increases in both the U.S. and Soviet navies, and America was about to raise the stakes yet again.
In 1980, President Reagan came in. He said, the Russian Navy is challenging our Navy. We're going to have a 600-ship Navy. This threw an enormous amount of construction to the shipyards that built for the Navy.
The new ships were some of the most sophisticated ever built. Engineers began to rely on computers to both design and build the extremely complex vessels. Today, the computer's workhorse cousin, the robot, lives on shop floors at places like the Northrop Grumman Newport News shipyard. This is the 6-axis ABB fully programmable robot. Its articulated arm moves similarly to a human's, but the welding torch at the tip does most of the work. Engineers download schematics directly into the machine, which then quickly welds the complex but often repetitive shapes. Machines like this have allowed shipyard builders to continue perfecting the efficient technique that originated during the First World War: modular construction.
More and more, the interior portions of the ship, such as the engines, come in modules. The engine's already been tested at the factory. You already know it works. The radar system has been fully assembled and put together in New Jersey and tested, and then as a unit, you know it works, then it's created and shipped off to the shipyards.
Today's shipyards are constantly fine-tuning their operations to maximize efficiency and maintain profits.
The shipyard of the immediate future is going to look a lot like the shipyard of today. We're still going to build ships out of steel because steel is relatively efficient and it's relatively inexpensive. We're going to use welding technology. The real improvements in shipbuilding are going to come from the ability to plan and to integrate. That I will be able to take design information, that information will go to every vendor, and the vendors will know instantly everything that changes and how it affects them.
But the shipyards of the future will depend on more than the savings brought on by proper planning. Throughout the 1980s, some shipyards, such as Newport News and the Bath Iron Works, thrived on substantial government orders for high-tech Navy ships. But Washington's actions nearly destroyed the rest of the industry by cutting subsidies that had kept the merchant shipbuilders afloat since the Great Depression. The loss meant merchant ship owners now paid more for ships built in America, and predictably, they looked overseas for cheaper, more efficient yards.
At the end of the Second World War, the Japanese and the Western Europeans had a great advantage over the United States because many of them were in the position that they could rebuild their shipyards. So basically they were starting with what you might think of as a clean sheet of paper so that they could lay out everything in the most advantageous way to minimize the cost of production. For example, it takes about 5 times the number of movements in a U.S. shipyard, all of which survived the Second World War as it does in a Southeast Asian shipyard.
The 1-2 punch of lost subsidies and more efficient foreign yards have had a profound effect on American shipyards.
When I graduated from the Naval Academy in 1980 with a naval architecture degree, there are 22 major shipyards in this country involved in ship construction. Today, there are basically 6. In 1982, we had about 112,000 people working in the industry. In 2002, production workers are about 45,000.
As shipyards disappear from American shores, they have almost no chance of being rebuilt, since public facilities or housing tracts gobble up the valuable beachfront property.
One of the largest shipyards in the United States, Hog Island, Pennsylvania, which was just south of Philadelphia, which was one of the most productive shipyards in the country in the 1920s, is now the Philadelphia International Airport. It would be very difficult to reclaim that back if you had to build a shipyard again.
But the biggest loss will have little to do with machinery or dry docks. The biggest concern for those in the business today is what happens to the shipbuilders once the yards go away.
There are some people that have been in those shipyards 20, 30, 40 years that are living encyclopedias on how you do things and how you do them right. And they've seen what can go wrong. And when you lose that experience, you can't just pick it up off the street again. It takes 30, 40 years to build.
Shipyards remain the places where builders use the world's largest tools to fashion the world's largest machines. But the loss of a shipyard is the loss of the age-old transfer of knowledge from master to apprentice. And that knowledge, once departed, may never find its way back to shore.
There are always going to be surprises.
You don't have to speak the language to be able to interact with people.
Knowing that can make you look at history in a new and exciting way.